You ever notice how some number patterns just click? Like there's some kind of hidden rule moving things along behind the scenes. Well, today, we're going to crack that code. We're going to uncover the super simple but really powerful logic behind these sequences. Let's dive right in. So, to get started, let's play a little game. I'm going to show you a couple of number sequences, and I want you to see if you can figure out the secret rule that connects them all. You ready? Okay, here's the first one. 2, 4, 6, 8, 10. What do you think is next? Yeah, you probably got it in like 2 seconds. Each number is just 2 more than the one before it. Simple enough. But what about this one? Now we've got 100, 95, 90, 85. See? Here, the numbers are going down. We're subtracting 5 each time. So that secret rule can go both ways. It can be adding something, or it can be subtracting something. Now, this secret rule isn't just some random little trick. It actually has a proper name in the world of math. And it's the key to figuring out any number in these patterns, no matter how far down the list you want to go. And here it is. It's called an arithmetic progression, or, AP for short. This is that aha moment. It just means it's a list of numbers where the gap between them is always the same. And that constant amount that you're adding or subtracting, we call that the common difference. And this is a perfect way to look at it. On the left, you've got that sequence that's growing, right? It has a positive common difference of +2. And on the right, you've got a sequence that's shrinking with a negative common difference of -5. Both of them are perfect arithmetic progressions. Okay, so to really start working with these things and unlock all their power, we need a little code-breaking toolkit. And here's the best part. There are only 3 essential pieces you need to know. That's it, just 3. And here is our entire toolkit. It's so much simpler than you think. First up, we've got A. That's just the first term, the number that kicks the whole thing off. Then we have D, our old friend, the common difference, that constant number we're adding or subtracting. And last, we have N, which is just the position of the term you're looking for. Like, are you looking for the 5th number, the 10th, the 100th? That's your N. Just A, D, and N. That's all we need. So, we've got the parts, right? We know our A, D, and N. Now we're going to put them all together to build the master key, a formula that lets us find any term in a sequence without having to write out the entire list. Let's actually build this thing together so it makes sense and you never forget it. Okay, the first term is just A, right? To get to the second term, what do? We add the difference once, so it's A plus 1D. For the third term, we've started at A and added the difference twice, so it's A plus 2Ds. Are you seeing the pattern here? For any term N, we're always adding the common difference one less time than its position number. So for the nth term, we add D exactly N minus 1 time. And all that logic leads us right here to this one beautiful formula. The value of any term N, we'll call it Tn, is just the first term A plus N minus 1 times the common difference D. This is our ultimate shortcut. Seriously, with this, you can find the 500th term just as easily as you can find the 5th without breaking a sweat. All right, that's enough theory. Let's be real. The best way to understand any tool is to actually use it. So let's take our new formula out for a spin and solve a problem right now. Okay, here's our mission. Find the 10th term of this sequence, 3, 7, 11, 15, and so on. Now, sure, we could just sit here and keep adding 4 over and over again, but that's slow and it's easy to make a mistake. Let's use our master formula instead. Okay, first things first, let's identify our variables. Our A, the first term, well, that's easy, it's 3. Our D, the common difference, we just do 7 minus 3 and we get 4. And N, the term we're looking for, the question tells us it's the 10th term, so N is 10. See? Simple. Now we just plug those numbers right into our formula. T10 equals our first term, 3, plus, and in parentheses, 10 minus 1 times our common difference of 4. Okay, so that simplifies to 3 plus 9 times 4, which is just 3 plus 36. And there it is, 39. The 10th term in this sequence is 39. Look how fast that was. No counting, no long lists. The formula did all the heavy lifting for us. Pretty cool, right? Hey, before we move on, just a quick heads up on a few common traps. First, always double check that the difference is constant. If it's not, well, it's not an AP. Second, make sure you're using the right N for the term you actually want. And a classic one, remember the very first term is position N equals 1, not N equals 0. So you might be thinking, okay, that's a cool math trick, but why should I care? When am I ever going to use this? And the answer is this simple straight line pattern shows up absolutely everywhere in the real world. I'm not kidding. This pattern is everywhere. Think about a salary that goes up by the same amount every year. That's an arithmetic progression. A savings plan where you put in, say, $50 every single month. That's an AP2. This idea is the foundation for modeling everything from financial growth to how an object moves in physics. It's not just some abstract math concept, it's the blueprint for any kind of steady, predictable change. So if you take away just one thing from all this, let it be this. An arithmetic progression is all about that constant difference. Once you find that D, you've got the power to predict any future number in that pattern. It's really the language of steady, linear growth. And this little formula right here, this is the key that unlocks it all. With this, you're not just looking at a boring list of numbers. You're actually understanding the engine that makes it run. Next time, we're going to take this a whole step further and figure out how to add up all the terms in a sequence. But for now, just think about it. What other patterns in your own life follow this simple, predictable rule?